Hello, welcome to the Ruby series on exorcism here at Ruby Gold. This video series goes through the exercises in the Ruby track on exercism.io, or I guess it's .org these days. So I have my progress here. I've reset my progress. In the previous video in this series, I did essentially go through one little exercise, but let me switch video feed here and we can take a look. So if you are starting out, your screen will be pretty similar. You may have already solved the hello world. As this series goes on, many more of these bubbles will be filled in. So don't worry if you're not caught up, but we are looking at the lasagna exercise. If you choose the Learn view, you can see it on this roadmap, and it is still the first exercise here. It's marked in progress simply because I've already clicked on it. But we will be solving these in the browser during this video series. So the quick overview, this teaches us some very simple things in Ruby, variables and constants, as well as some of the basics of classes and so forth. You can, of course, read through these in your own time. We're going to jump into the editor. So we can see we've got a class here, Lasagna, in the lasagna.rb file. And we have some results to check on. And so if we run our tests to start, because I think it's a good place to start, we will see that all 6 tests failed, which is kind of a good thing. And we can look and see that there are some assertions in these tests. I think it's a good idea to sort of run your test suite first in Exercism, get the failures, see what's happening, and sort of work from a TDD mentality. Throughout this video series, I'm going to try to work somewhat roughly of a TDD mentality, not entirely. I won't be dogmatic about it, but I'll do a little bit. So we can see our test 1 failed. We expected minutes in oven. So what that looks like is there was an assertion of 40, and that's kind of what we expected to get back. So let's assume that we called the lasagna class. So if you're new to Ruby, essentially we have here a thing called lasagna, and then we're using this double colon notation to call something on this class, which happens to be, in this case, a constant called expected minutes in oven. And this constant, you can tell it's constant because it starts with an uppercase, specifically an uppercase letter. And that's a little bit of a Ruby thing. So typically we will store constants at the top of our file here. And if I write this, my expected minutes, wow, in oven, and set that equal, in this case, to, well, we're assuming it's 40. Let's check our instructions over here and see if that's consistent. So it definitely wants us to define this constant, and it should be equal to 40. So let me just make that equal to 40. And if I run my test suite again, and with testing, we generally want to make the smallest change possible. We can see that this still failed because apparently I don't know anything about Ruby. Yeah, no, it's not because I don't know anything about Ruby. It's because I'm having trouble typing today. So if we name the constant correctly, and this is, the smallest change possible. Let's run the test suite again and see if things go better this time. All right. Yeah, so one test passed. So that's excellent. That's progress, right? Hooray. We already have a little bit of a success here. And so continuing down a TDD mentality here, we can look at the next test. So next thing we have is a test on remaining minutes in oven. So we're expecting that to be 15. So this is where things get a little bit different. With the constant, which we could define and set to a value, the instructions pretty much told us to do exactly that. Define the constant and set it to a value. The next thing here is a little bit different because our test suite starts to test that we actually receive, that our methods receive parameters and return values. So this is actually testing the execution of the code, a little bit more of the like real world functionality, as opposed to with the constant, we're setting a value. So it's pretty straightforward. Here, we're actually working on behavior. So essentially remaining minutes in oven, which we already have a method stubbed out here. And we can see that this is set up to take an argument, actual minutes in oven, and do something. So right now it raises an error. During the test run, please implement this method, which we should see. Please implement this method. So first things first, if we get rid of that, and this is really the simplest change possible, now we still get a failure, but it doesn't yell at us that same way. What it does is it yells at us because the assert value is nothing. And so the assertion was 15, the actual was nil. And we should expect that to be nil because our method returns nothing. So we're calling this method and returning nothing. I could cheat, perhaps, and return 15. And we can see my test did pass, but that's not very good because unlike the constants, as I belabor this point, we can't just set that. We need to actually take a value in here. So the sort of bouncing back and forth between the test and the requirements is this concept that the remaining time in oven is essentially the difference, right? We could think about it that way, of the expected time in minutes, or expected minutes in oven, minus the actual minutes in oven. So here we're doing a little bit of math. We're taking the constant, which is a value. So that's essentially the same as saying 40 minus actual minutes in oven, which will be passed in. So in the test case here, if it's 15, we would expect this to be 25. So we're expecting that. And so if we take our extra line out here, let's run this and see what we get back. All right, so our test passed again, and that's a great demonstration. I know it's very simple. I assume if you're watching this video, you're probably a little bit newer to Ruby, possibly newer to testing as well. And it's kind of interesting to show that to you, how you can pass tests without actually having your code perform the way it's meant to be. So this is a good example where we sort of iterated over this, and we can like make the test pass manually by putting in a value, but we then fix it and our test remains passing, which means the functionality is probably what we need it to be now, which is great because now we have 2 tests passing. We have a long row to go. We have 4 more tests, but I don't think they're going to be too bad. So you could, at this point, continue down just reading the tests to try and pass them one by one. That's a very test-driven way. Or you could jump back to the instructions and see. And the reason I bring this up now is because we only have 4 steps to solve this puzzle or this exercise, but we have a total of 6 tests, which means some of our tests might overlap for which part of the exercise we're solving. So we kind of have to like do that juggling, the testing and the requirements to see, to fix this, what information do we need to know? Now, reading it, we're basically reading, we can see, please implement. That gives us an indication that we're looking at a new piece of the code, so one of our other methods. And so we can probably assume that this first method is done, at least for now. If we come back into our instructions, we pass this case, so we're probably over here, and the names do match up, preparation time in minutes. So preparation time in minutes. And we saw this was the error that was raised. So we can get rid of that. I'm not going to run it right now because that would be a little bit silly. I did it in the first exercise just to demonstrate the point. But here, let's maybe get some actual output before we run it. So preparation time in minutes. Here, it might be a little bit helpful to read the requirement. So assuming that each layer takes 2 minutes to prepare, essentially we have a case where we're doing, again, some math that's basically 2 minutes a layer. So the simple way to do that might be to do something like layers times 2. So let's watch what happens if we run the test. And it looks like an additional 2 tests passed, so that's pretty good. Now, we have here a case where we passed the test, and that's good. In this next thing, you can either do at the end of this exercise, you can avoid doing it entirely, or you can do it right now. We're going to do it right now. We have code that is passing 2 tests, and it looks like if we just take a peek here, our next tests are probably for something different. So I want to take this moment to look at these 2 tests that did pass. And we can see essentially what happened was that 2 different numbers were passed in. So there's 2 different tests, basically ensuring that 2 different numbers both generate correct outputs. So in one case, it was essentially 1 times 2 equals 2. In the other case, it was 4 times 2 equals 8. This 2 is an interesting little piece here. It's some people call it a magic number. I usually call it such. And the reason for that is, where does it come from? What does it mean, right? If future you, after you write this code, has to come back to it, or someone else on your team has to come back to it, what is this 2? Why is it 2? Can we change it? What happens if we try that? And so this is a great opportunity where we can take this away and maybe do another constant here, so that, especially if we need to use this calculation elsewhere. Now, this exercise is pretty simple. We're only using it in one place. But even still, it does give us a little bit more clarity if we perhaps create a constant. So essentially, if we look at the instructions, maybe we can get a name from here. Each layer takes 2 minutes to prepare. So maybe something like whoops, I guess my caps lock isn't working. Preparation, that's a preparation time. Let's make it something a little bit, I was going to say preparation time per layer. That's a little wordy. So let's make it something like layer preparation time. So it's not that different of a name, but naming things is very hard. And I feel like there's a little bit better reading of layer preparation time. So, right, we have like subject, adjective, noun, I think. Whatever the parts of speech are. But layer preparation time, it's like a thing now. This is the time, whereas preparation time per layer is a little bit, it's just too verbose in my mind. This makes it a little clearer, like we need the layer preparation time. It sounds a little bit more like what you might actually say. So we can still set it to 2, and then we can take this and put it in place here. So now we're doing a very similar thing to our previous method. And if we run these tests, we should see that we still pass 4 of them. It's the same for tests 1, 2, 3, and 4. And so we just have those final 2 tests to resolve. And we did not break anything in this step, so we can probably move on and feel pretty assured that our first 2 methods are probably solved and we're more than halfway through. So let's take a look at the next one. And again, I like reading these from the tests. So we know we're going to get rid of this error here. I'm not even looking at the test yet. I'm just looking at the sort of skeleton here. We can see that it actually takes 2 things, and they're written a little bit differently than the way that the other methods are written. So now I'll take a look here and see what's going on. I have a number of layers, and I have an actual minutes in oven. And so frankly, what I'm doing is sort of practicing a little bit of ignorance in the sense that I'm not even reading like the method name yet. I'm just sort of looking at like what are the inputs and outputs and taking my test to determine, because this test suite was written by someone who, you know, prepared it specifically for this exercise, right? In a real code base, it might be a little, you have to play around a little bit more because we all know the previous developers wrote bad code, right? That's, I mean, it's a little silly, a tongue-in-cheek thing. Oftentimes you are the previous developer who wrote the bad code. But anyway, the point is sometimes our tests don't tell us what we need exactly. So you can't always take the tests and work on the code from them. But just to get in sort of this habit, this practice of test-driven development, TDD, is if we look at our tests, we can sort of deconstruct and see what our code should do and what it should look like. So we know that it's called with 2 methods. And you can surmise that maybe the reason this is different is because in the first exercise and the first and second methods, we only had 1 variable, whereas here it's a little bit different. And so we essentially are making sure that when we call this method here, we're actually doing a couple of things. We're sort of taking away these positional arguments here, and we're giving them, essentially allowing them to be called by a name. So you can sort of see in these other examples, we just call it with the number because the argument is positional and it doesn't use a keyword. Whereas here, we're actually specifying that you need to call it with a keyword. So if you tried to call it without the keywords and just positional, this would actually fail. Or specifically, it would throw an error at you about, well, it depends on which thing you changed. But yeah, so you would actually get an error, probably an argument error. Conversation for another time. But this is what we get. So it doesn't change much about our behavior going forward. We can still reference these, number of layers. We don't have to do anything differently there. It's just when we invoke the method, when we send this method on our class or our instance, we have to specify those, and you see that. Same with the second one, assuming it's a test for the same method, it's called similarly here in the test suite. So essentially, we have sort of pulled out all the information perhaps we can from this test. We're going to get 1 number back. So I guess that's 1 extra bit of information. We know it's going to be a number, and that's consistent because it's time in minutes. So we can sort of extrapolate from that. Like in this example, for instance, 30 minutes in the oven. So we know the number is probably going to be 30 or greater. And then number of layers sounds kind of like the previous method. And we can sort of extrapolate. So 1 layer, 2 minutes, plus 30 minutes, 32. And then I'm assuming this would be a similar thing. Number of layers, 4 times 2 minutes a layer. So that's 8 minutes. Add that to the actual minutes in oven. That's 16. So that's probably what's going to happen here. So we could do a number of things here. And I'm not even going to look at the instructions. I just want to see if we can write this, just extrapolating from it. So we know that essentially we're going to get a number plus another number. And so this first number here We can do whichever one of these is necessary. I'm going to actually start with this here, the actual minutes in oven. So essentially, I don't have to do any real calculations here. This is just a number that's going to get passed in. And then this one is my number of layers. So if I do this, I'm passing in actual number of minutes in oven and number of layers. That test suite should fail. There could potentially be a test that passes, but not likely because we're doing a multiple of 2. But in this case here, we can see it fails, and that's as it should. So we have to sort of choose, are either of these operands invalid for some reason? And I would argue it's the number of layers, because we know that number of layers have this sort of preparation time in minutes. So we know that's kind of something times 2, right? Times use our constant here. We know that this comes out. And so maybe something like this. Oh, hooray, look at that, we passed. But this is one of those scenarios where we kind of did things inefficiently. We wrote this whole method up here and didn't even use it. Arguably, we wrote this method and didn't use it either. But this seems sort of like inefficient if our whole goal is basically, if you look at it, we're recreating what's in here. So maybe a better thing to do would be something like, if we take this method and we pass in the number of layers. Maybe that gets us what we want. Let's run the test suite. Hey, look at, we passed again. Excellent. So this looks pretty good overall. We could come back and do things like we could, if we wanted to, we could tweak all of these. Now that's going to break our tests because we can't modify our tests. See, here is the argument error, wrong number of arguments given 1, expected 0. So like we kind of broke the way that these work. If we could modify our tests, we could do something like that. And then that should hopefully start giving you the idea that, like, well, if we modify it here, we're gonna have to modify it there and maybe elsewhere. So sort of outside the scope of this video, but you start to see how like little changes can have a great sort of echo throughout your code base. But we have just a simple thing here. So let's run that once more, make sure that we're still in good shape. And so we see that it passes. We created a second. So this is something different where we were never instructed, I don't think, to ever create that second variable. I'm sorry, the second constant. But I think we can sort of agree it's better use, even though we still only use it in one location. We sort of see all these, quote, magic numbers in one location. And so now that we've like completed this exercise, I think if you're new to Ruby, you can see the benefit. And, you know, it's easy to go overboard and create a bunch of constants. And depending on your application, you might have more or fewer than other people do in their applications. It really comes down to what you're building. But for an exercise like this, I think it's the sweet spot. There's two magic numbers, so let's make 2 constants. You can endlessly tweak the names of them if you wanted to. You could do, I wouldn't recommend this, but we were talking about in the instructions or in the test suite, we saw something like this. So you could technically like call them like this and run the test suite, and this should still pass, but also that's a little bit silly. And this would be if you needed to invoke them from somewhere else, from a different class. But because these are here in this class, they are methods within their instance methods within this class. So they are available because we're still within the scope of our class Lasagna. And Yeah, I think that's pretty good. I'll run the test suite one more time. I know I changed something. It's still good, so we're going to submit that. Yeah, so no immediate feedback from the system. Here, if you're following along, you could request a code review. Maybe you made some changes differently from mine, and someone would mentor you, and that's one of the beauties of Exercism. I'm not going to do that, however. I'm just going to pass it this video. So if you're watching this, you probably already know this, but this will show up in the dig deeper section. And so you can watch this video, and if anyone else has a video on this particular exercise. Yeah, so since this is the first true video in the series, I'm just spending a little bit more time talking about what you see on the screen here. But you can go through, you can see your iterations. So perhaps we passed all the tests and submitted it. Actually, if we go back and do that, here's a good example. So we started out doing something a little funky, right? We had essentially, we were trying to do something like this. And if we run those tests, they pass. But this is one of those things where the automated tests will come and sort of catch you. And well, okay, so we did not actually get any automatic feedback, but you can see that there's 2 iterations. Now it's kind of funny because really, like, this was clearly the better way to do it. So I was expecting that the analysis would tell me that this could be improved, but it doesn't, and that's fine. I'm going to just undo this because it doesn't make any sense to me to do it this way. So we can do that. Presumably we could do Seattle style and write our method like that. Nope, never mind. That's not going to work. So forget I said that. Run this one more time, pass it, and submit it, and we are done. Community solutions are a great place to see how other people solve the puzzle. So my video is one way. The community solutions are a great way. Code review is wonderful. The mentorship on Exercism is incredible, highly valuable. Yeah, and then once you're done, once you're satisfied with everything, you've gotten all the mentorship you want, you've done as many iterations as you want, you've done everything, you can mark as complete. You can either share a single iteration or all your iterations. Or you can not share anything. I'll just share everything and we're good. Awesome. So that is the Lasagna exercise, the first true Ruby exercise here in the Exercism track. I appreciate you watching this video. Give it a thumbs up if you're watching it on YouTube. Feedback's nice. If you're going to watch more of these, you can watch them right in line on the Exercism track in the Dig Deeper section, or you can subscribe and follow the videos right here on YouTube. Whatever's more convenient to you. Anyway, again, I thank you for being here and watching this video, and I hope you learned something from it. Leave me some comments if I taught you something you didn't already know. All right, signing off, and remember, there's gold in them rubies.